Students, the next topic is resonance. So, what is resonance? Resonance circuit andre it's a combination of RLC, resistor, inductor, and capacitor, in which the response is maximum for the frequency, that is FR. Andre for a particular frequency called FR, resonating frequency olagaste, the response will be maximum, and it decreases beyond this limit. A limit bit to the left or to the right adu enagtೈತಿ decrease ಆಗಿರ್ತೈತಿ. And this concept is used in tuning ಒಳಗೆ ಯೂಸ್ ಮಾಡ್ತಾರ. This is example, this is a maximum resonating frequency, ಈ ಕಡೆ ಅದು decrease ಆಗಿದೆ. So the resonant circuit ಅಂದ್ರೆ it will have both L and C, inductor and capacitor, when the resonance occurs. The resonant circuit will have both L and C. When resonance occurs, ಅವಾಗ ಏನಾಗ್ತದೆ, energy absorbed by one reactive element is equal to another, XL equal to XC ಇರ್ತೈತಿ. ಅಂದ್ರೆ during resonance, inductive reactance equal to capacitive reactance. Next, the average power which is absorbed by the system is also maximum at resonance. So, this is one point to be noted. And what are the uses? Tuning in the radio and TV circuits use ಆಗ್ತೈತಿ, and the tuned circuits in communication fields such as sonar, radar, etc. What are the different types of resonance? So, number one, series resonance, and number two, parallel resonance. What is series resonance? When R, L, C are connected in series, the configuration is called as series resonance, and it is also called as voltage resonance or acceptor circuit anta ನಾವು ಕರಿತೇವಿ. Here both VC and VL ಅಂದ್ರೆ voltage at capacitor and inductor, they are equal in magnitude and opposite in phase, and hence they cancel each other. And next topic is, what are the condition for resonance? So since XC is greater than XL andre capacitive reactance is greater than inductive reactance idra capacitor dominance irtati, it is capacitive in nature. XL greater than XC idra inductive in nature. ಎರಡು ಈಕ್ವಲ್ ಇತ್ತಂದ್ರೆ ಅವಾಗ ರೆಸೊನೆನ್ಸ್ ಆಗ್ತೈತಿ ಅವಾಗ. and Fs is 1/2π√LC. So what is inductive reactance, what is capacitive reactance? Andre inductive reactance is the opposition offered by the inductor for the flow of AC supply, that is XL. Capacitive reactance XC andre it is the opposition offered by the AC supply, it is the opposition offered by the capacitor for the flow of AC supply. Andre AC current ಹರಿಯೋದಕ್ಕೆ capacitor in opposition ತೋರಿಸ್ತೈತಿ, ಅದಕ್ಕೆ capacitive reactance XC ಅಂತ ಕರಿತೇವಿ. and inductor in opposition ತೋರಿಸ್ತೈತಿ, ಅದಕ್ಕೆ inductive reactance XL ಅಂತ ಕರಿತೇವಿ. and what is impedance? Impedance is sum of all. Impedance is nothing but the total sum of opposition offered for the flow of AC supply by the resistor, by the inductor, by the capacitor. Resistor resistance ಕೊಡ್ತೈತಿ, capacitor capacitive reactance, and inductor inductive reactance ಕೊಡ್ತೈತಿ. and during resonance XL equal to XC and ZS is under the root of R square, that is R ಆಗ್ತದೆ. and current here is V by R. Next concept, what is quality factor QF? The quality factor is nothing but it's a ratio of reactive power of the inductor or a capacitor to average power of the resistor. So ಈ ratio ನಾವು quality factor ಅಂತ ಕರಿತೀವಿ, given by QS equal to XL by R ಅಥವಾ XC divided by R. ಆದ್ರೆ at resonance what happens? QS equal to 1 by R under the root of L by C. So you have to remember this formula. Next top concept is power factor. Power factor ಅಂದ್ರೆ ಏನು? Power factor is cos theta. Cos of angle theta is power factor. Suppose angle ಇಲ್ಲಿ 0 ಇದ್ರೆ cos 0 is 1 andre, therefore because during resonance XL equal to XR and hence reactance is 0, theta 0 ಇದಕ್ಕೆ cos of 0 is 1, power factor 1 ಆಗ್ತೈತಿ. and next concept, bandwidth. Bandwidth ಅಂದ್ರೆ ಏನು? difference between the frequencies F2 minus F1 sorry, the range of frequency over which the power in the circuit is 50% of its maximum value. So the power in the circuit is 50% ಆದಾಗ ಅವಾಗೇನು range of frequency ಇರ್ತದೆ, that is called bandwidth. and the F1 and F2 are half power frequencies, also known as 3 dB frequencies, also known as cutoff frequency. F1 and F2 are half power or 3 dB, and bandwidth equal to Fs by Qs. Next concept, parallel resonance. Parallel resonance Fp equal to 1/2π under the root of 1 by LC minus R square by L square, and impedance is given by Zp equal to L divided by Cr, and current IP equal to V divided by L by Cr, and quality factor, that is QP equal to QS XL by R or equal to XC divided by R, and power factor is cos theta cos phi equal to 1, and bandwidth here in this case f2 minus f1 or fp by qp, and in the parallel resonance fp equal to fs under the root of 1 minus 1 divided by qs square. This is regarding the parallel resonance and series resonance. Next concept is filter. Filters andre eno? Filter is nothing but a frequency selective network which is designed to pass ಅಥವಾ ರಿಜೆಕ್ಟ್ the signals of certain frequency. ಕೆಲವೊಂದು ಫ್ರೀಕ್ವೆನ್ಸಿಯನ್ನು ಪಾಸ್ ಮಾಡ್ಬೋದು, ಕೆಲವೊಂದು ಫ್ರೀಕ್ವೆನ್ಸಿಯನ್ನು ರಿಜೆಕ್ಟ್ ಮಾಡ್ಬೋದು. ಆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಸೆಲೆಕ್ಟಿವ್ ನೆಟ್ವರ್ಕ್ಗೆ ನಾವು ಫಿಲ್ಟರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. We have a passive filters. Passive filters uses the passive components such as RLCs. And next, pass band and stop band definition. Pass band ಅಂದ್ರೆ a range of frequency the filter will passes. So faithfully ಯಾವ range frequency pass ಮಾಡ್ತದ, that range is called pass band, and the range of frequency the filter attenuates ಅಥವಾ reject ಮಾಡ್ತೈತಿ, that is called stop band. Next very important point, cutoff frequency andre it is the frequency at which the output of the filter drops by 3 dB from the pass band. Pass band ಕಿಂತ 3 dB drop ಆಗೋ ಪಾಯಿಂಟ್ ಗೆ cutoff frequencies ಅಂತ ಕರಿತೀವಿ. But for an ideal filter, ideal andre which is true only in paper, the attenuation is 0 and for the pass band and infinity for the stop band. So ideal filter characteristics point to be noted, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ CT point of view. Ideal filter attenuation should be 0 for the pass band and infinity for the stop band. Pass band ಒಳಗೆ 0 ಇರಬೇಕು, stop band ನಾಗ infinite ಇರಬೇಕು. What are the types? We have different types: low pass filter, band pass filter, band reject filter. Low pass filter ಅಂದ್ರೆ which passes the low range of frequencies. So this is ideal. And so ideal ಅಂದ್ರೆ for example think that 0 to 5 kilohertz ಅಷ್ಟೇ ಪಾಸ್ ಮಾಡ್ತೈತಿ, ಅಬೋವ್ 5 ಸ್ಟಾಪ್ ಮಾಡಬೇಕು. ಸೊ 0 to 5 ಪಾಸ್ ಮಾಡ್ತೈತಿ, ಎಕ್ಸಾಕ್ಟ್ಲಿ ಅಬೋವ್ 5.1 ಸ್ಟಾಪ್ ಮಾಡ್ತೈತಿ. ದಿಸ್ ಈಸ್ ಐಡಿಯಲ್ ಗ್ರಾಫ್. ಬಟ್ ಪ್ರಾಕ್ಟಿಕಲಿ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಹಂಗೆ ಆಗಂಗಿಲ್ಲ, ಸ್ವಲ್ಪ ವಿಲ್ ಗೆಟ್ ಅ ಬೆಂಡ್. ಸೊ ಐಡಿಯಲ್ ಗ್ರಾಫ್ ಆ್ಯಂಡ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಗ್ರಾಫ್ ದೇರ್ ವಿಲ್ ಬಿ ಅ ಡಿಫ್ರೆನ್ಸ್. ದಿಸ್ ಈಸ್ ಐಡಿಯಲ್ ಅವರ್ ಎಕ್ಸ್ಪೆಕ್ಟೇಷನ್. ಎಕ್ಸಾಕ್ಟ್ಲಿ 0 to 5 ಪಾಸ್ ಮಾಡಬೇಕು, ಅಬೋವ್ ಗ್ರೇಟರ್ ದೆನ್ 5 kilohertz ಇಟ್ ಶುಡ್ ಸ್ಟಾಪ್. ದಿಸ್ ಇಸ್ ಐಡಿಯಲ್ ಸರ್ಕ್ಯೂಟ್. and this is a T section. So L by 2, and this is C, this is T section, and this is pi section, this is L, C by 2, C by 2, and here C equal to 1 divided by pi R naught F naught, and cutoff frequency FC is equals to 1 divided by pi under the root LC. FC is 1 by pi under the root LC. Next, high pass filter which passes the signals only above. So okay, it is going to pass the signals only above particular limit, and the cutoff frequency is FL. See here 0 to, for example 0 to 5 kilohertz stop ಆಗಬೇಕು, above 5 kilohertz ಅಷ್ಟೇ ಪಾಸ್ ಆಗಬೇಕು. ಸೊ above particular limit ಅಷ್ಟೇ ಪಾಸ್ ಮಾಡ್ತೈತಿ. 0 to 5 total stop, more than 5 kilohertz ಪಾಸ್ ಮಾಡ್ತೈತಿ. And this is the high pass filter T section using 2 capacitors, 1 inductor, and pi filter 1 capacitor and 2 inductors. And these are the formulas: C equal to 1 by 4 pi R naught FC, and FC 1 divided by 4 pi under the root LC. Half pass, low pass and high pass. Band pass andra a certain band of frequency will be passed. It has a bandwidth between two cutoff frequencies FL and FH, and this filter can be realized by connecting low pass and high pass in series. So high pass low pass series connect ಮಾಡಿದಾಗ ಕೂಡ ನಮಗೆ ಈ ತರ ಸರ್ಕ್ಯೂಟ್ ಸಿಗ್ತದೆ. low pass and high pass ಎರಡನ್ನು ನಾವು series ಒಳಗೆ connect ಮಾಡಿದಾಗ, so when both high pass and low pass are connected in series, we are going to obtain band pass. And cutoff frequency of low pass must be more than that of a high pass. So for example, see that 0 to 5 kilohertz stop ಆಗಬೇಕು, 5 to 10 kilohertz ಪಾಸ್ ಆಗಬೇಕು, above 10 ಸ್ಟಾಪ್ ಆಗಬೇಕು. ಸೊ ನಮಗೆ ರೇಂಜ್ ಏನಪ್ಪ, ಬಿಟ್ವೀನ್ 5 kilo to 10 kilohertz ಅಷ್ಟೇ ಪಾಸ್ ಆಗಬೇಕಂದ್ರೆ ದಿಸ್ ಇಸ್ ಅ ಬ್ಯಾಂಡ್ ಪಾಸ್. ದಿಸ್ ಇಸ್ ಐಡಿಯಲ್ ಗ್ರಾಫ್ ವಾಟ್ ವಿ ಎಕ್ಸ್ಪೆಕ್ಟ್. And next we have the opposite way, that is a band stop ಅಥವಾ band reject filter or band elimination. Band reject, band elimination, band stop, the different name. It's the total opposite. 0 to 5k stop ಆಗಬೇಕು, okay, and 5 to 10k pass ಆಗಬೇಕು. Sorry, so this is a total opposite. So things has to be changed here, because see here, so 0 to 5k has to be passed, 5 to 10k has to be stopped, and more than 10k has to be passed. So it's a total opposite. See here, the correction has to be made. So bands pass ಅಲ್ಲಿ ಏನಾಗಿದೆ, 0 to, for example 0 to 5k ಸ್ಟಾಪ್ ಆಗಬೇಕು, 5 to 10K ಪಾಸ್ ಆಗಬೇಕು, 10K ಅಬೋವ್ ಸ್ಟಾಪ್ ಆಗಬೇಕು. ಅಂದರೆ 5K to 10K ಅಷ್ಟೇ ಪಾಸ್ ಆಗಬೇಕು. ದಿಸ್ ಈಸ್ ಬ್ಯಾಂಡ್ ಪಾಸ್. ಆ್ಯಂಡ್ ಇನ್ ಬ್ಯಾಂಡ್ ಎಲಿಮಿನೇಷನ್ ಇಟ್ ಈಸ್ ಟೋಟಲ್ ರಿವರ್ಸ್. 0 to suppose think that for example 0 to 5K ಪಾಸ್ ಆಗಬೇಕು, 5 to 10K ಸ್ಟಾಪ್ ಆಗಬೇಕು, ಅಬೌವ್ 10K ಪಾಸ್ ಆಗಬೇಕು. ಸೊ this is a stop band here, left right pass band. In band pass it was a reverse. So this is a band reject filter. This has to be corrected. Point to be noted. So idanna ನೀವು correction ಮಾಡ್ಕೊಳ್ರಿ. So this is a pass band. Next we stop band here. Again this is a pass band. And this band reject or elimination filter ಹೆಂಗೆ ಫಾರ್ಮ್ ಮಾಡಬಹುದು, ಯೂಸಿಂಗ್ ಟು ಲೋ ಪಾಸ್, ಒಂದು ಲೋ ಪಾಸ್ ಆ್ಯಂಡ್ ಹೈ ಪಾಸ್ ಕನೆಕ್ಟೆಡ್ ಇನ್ ಪ್ಯಾರಲಲ್. ಸೊ ದ ಬ್ಯಾಂಡ್ ರಿಜೆಕ್ಟ್ ಫಿಲ್ಟರ್ ಇಟ್ ಬ್ಲಾಕ್ಸ್ a band of frequency between FH and FL, and it is a inverse of a band pass filter, and this can be realized by using one LPF and HPF connected in parallel, and cutoff frequency of low pass should be less than cutoff frequency of high pass. ಅಲ್ಲೇ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಇರ್ತಿತ್ತು ಬ್ಯಾಂಡ್ ಪಾಸ್ನಾಗ, ಇಲ್ಲೇ ಲೆಸ್ ದ್ಯಾನ್ ಇರ್ತೈತಿ. Okay, this is regarding band elimination, and students please make the correction here. Next topic is attenuator. Attenuator ಅಂದ್ರೆ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಇಟ್ಸ್ ಅ 4 terminal network which is inserted between the source and load. ಸೋರ್ಸ್ ಮತ್ತು ಲೋಡ್ ಮಧ್ಯದಲ್ಲಿ ಅದನ್ನು ಇನ್ಸರ್ಟ್ ಮಾಡಲಾಗ್ತದೆ. ಅದೇನು ಮಾಡ್ತೈತಿ, ವಿಚ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಇಂಟ್ರೊಡ್ಯೂಸ್ ಅ ಸ್ಪೆಸಿಫಿಕ್ ಅಮೌಂಟ್ ಆಫ್ ಲಾಸ್. ಪರ್ಪಸ್ಲಿ ಅದು ಲಾಸನ್ನು ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತೈತಿ. ಲಾಸನ್ನು ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡೋ ಸಂಬಂಧ ನಾವು ಅದನ್ನು ಇನ್ಸರ್ಟ್ ಮಾಡ್ತೇವೆ. It's a purely resistive network and no phase shift is involved here, and it is used for resistive impedance matching purpose ಗೆ ಯೂಸ್ ಮಾಡ್ತೇವೆ. It is used for resistive impedance matching in place of transformer. So transformer ಬದಲಾಗಿ impedance matching ಸಂಬಂಧ ಯೂಸ್ ಮಾಡ್ತೇವೆ. And it is always expressed in decibel dB, and D is equal to 10 log of PS by PR to the base 10, or D equal to 20 log to the base 10 IS by IR, which is equal to 20 log of EN to the base 10. And attenuation in Napier ಒಳಗೆ ಕೂಡ ನಾವು ಡಿಫೈನ್ ಮಾಡ್ಬೋದು as log of n to the base e, and Napier is a small unit compared to decibel. Decibel kintano it is a very very smallest, and very important point to be noted from CT point of view ಏನಪ್ಪಾ ಅಂದ್ರೆ ನೆನಪಿಟ್ಕೊಡ್ರಿ, ಇದು attenuation in dB is equal to 8.686 into attenuation in Napier. ಸೊ ನಮಗೆ attenuation in Napier ಗೊತ್ತಿತ್ತಂದ್ರೆ 8.68 ಜೋಡಿ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ attenuation in dB ಸಿಗ್ತೈತಿ. ಆರ್ ನಮಗೆ attenuation in Napier ಬೇಕಂದ್ರೆ ಗಿವನ್ attenuation in dB ನ 0.115 ಜೋಡಿ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ರಿ, then we'll get attenuation in Napier. Therefore I will repeat, attenuation in dB is equal to 8.686 into attenuation in Napier, ಅಥವಾ attenuation in Napier ಬೇಕಂದ್ರೆ attenuation Napier equal to 0.115 into attenuation in dB. In this way we can obtain the attenuation in decibels athava Napier. There is a definite relationship between dB and Napier. In the next video we will continue with the different types, symmetrical and asymmetrical attenuators, etc.